Okay guys, so what I've just done is I took a solution of vitamin C and water from this beaker, put it into this beaker with a solution of hydrogen peroxide. Um, Sorry, this was vitamin C and iodine. This one was hydrogen peroxide and water. So I just kind of poured this into one beaker and mixed the two solutions, and now we're just waiting for the reaction. So while we're waiting for the reaction to occur, I'm going to go ahead and just kind of talk about it for a little bit. So what's happening is in solution A, we had the vitamin C and the colorless I- minus ions. And then in solution B, we had the hydrogen peroxide and the cornstarch. And when I pour these two solutions together and mix them, they start to react with each other. But interestingly, it is not just one reaction that's occurring. There are two reactions occurring right now. So the two reactions right now are kind of in a competition. One's just trying to push one the other way. They're just kind of pushing each other back and forth, just seeing which one can overcome the other. So specifically, the hydrogen peroxide is attempting to oxidize the I minus back into colored I2. So oxidation is a loss in electrons. So the hydrogen peroxide is trying to change this I minus, colorless I minus iodine into colored I2. And then inversely, the ascorbic acid is wanting to reduce or add electrons to the iodine. So while hydrogen peroxide is trying to turn the I minus into I2, the ascorbic acid is trying to turn the I2 back into I minus. So there you can see how we're just kind of going back and forth. So the I2 does not last very long. The vitamin C in this reaction here is going to be consumed because of it's going to be consumed because of an excess amount of hydrogen peroxide. So therefore, the I2 is going to accumulate since it's eliminating the ascorbic acid, which wants to bring it back to I minus. So the hydrogen peroxide is taking over the ascorbic acid, turning it into I2. Then the I2 is going to complex with the I minus to then produce triiodine, to produce a triiodine complex, which then the triiodine is also going to complex with the cornstarch. The concentration of the reaction as well as temperature of this reaction are going to affect how fast the reaction occurs. So if I were to increase the concentration of either I2 or I minus, it's going to cause the reaction to occur faster. Another thing that I could do in order to increase the speed of this reaction would be if I were to increase the temperature as well. But it would actually take longer if I were to increase the amount of ascorbic acid or vitamin C being put in here. So kind of with a vice versa type deal with increasing the temperature, we're going to, if we were to decrease the temperature, it would actually decrease the speed at which this is going to happen. So as we wait for this to go, I'm going to try and see if I can speed this up. So in order for me to speed this up, I can go ahead, I can try to stir it. So the reason it's taking so long could be because it could be too much of a concentration of vitamin C, making it take longer than it should, or the temperature of this could be too low for what we're looking for. But if I would have decreased, maybe just use one. I use 2 tablets of 1,000 milligram vitamin C. If I would have just used one, it probably would have changed the speed of it quite a bit. So sorry we couldn't get it to react within our time frame, but hopefully next time when I try it again it'll work.